Yes. So we've successfully finished the 3 mark small derivation. That's all about Brewster's law. What is Brewster's angle or polarizing angle also we have discussed. So what is polarizing angle? The angle for which, okay, better take down separately as a definition, okay. Right, take down polarizing angle. So how to define this? The angle for which the incident unpolarized light is completely polarized after reflection. This angle is called polarizing angle. Okay, take down polarizing angle. That means angle of incidence for which reflected ray is completely plane polarized. Like that also in short you can write down. Okay, done. So that is all about polarizing angle. Next, one more question. It's a general knowledge question. Okay, you can take down. Does wavelength of light and okay, polarizing angle are dependent? Particular question, okay. Does wavelength of light in and polarizing angle of light, okay, angle are dependent? That means whether it has got any relation between them. Here experimentally or with any derivations we don't discuss. Okay, answer will tell you. Right now we have done one small derivation as well as reflection of light concept in which polarization is occurring and we have observed it. Brewster's angle, Brewster's law. Here what we have assumed is the ray of light is normal white light, correct? That means consisting of VIBGR. Now imagine that you are incidenting or you are making a ray of light to incident is colored one, maybe blue colored light ray, white, yellow colored light ray or any other green. In this case what happens? Whether you are going to get same angle of polarizing angle like how we got for water 53 degree 4 minutes as well as glass, something like that. Answer is no. When wavelength varies, polarizing angle also varies. So just remember students what I told you right now. So yes, of course, what is the answer? Yes. What is the relation? So polarizing angle is inversely proportional to wavelength of light. In sentence you write down and this one also you can write down. So polarizing angle is inversely proportional to wavelength. Yes. So if you use different wavelengths of light, different polarizing angle you will get. Okay. So write down definition. Fine then. Let us go for next applications and all those concepts in polarization. So students, while beginning the concept of polarization, I told you people something regarding sunglass, okay, and LCD displays like calculator, your digital watch. There and all, polarization concept is being used in the displays. Told you, sunglass also. If you purchase polarized sunglasses, means it is well and good for your eyes. Whereas if you just use some less expensive colored kind of sunglasses, of course we can't give you 100% sure that it's good for your eyes, health of your eye, whatever. So today what we are going to do is, fine then. So I told yes sir, you told that polarized sunglasses are there. How it is made? Okay, let us see. See, these polarized sunglasses or polarized glass sheets are being used in different applications. For example, in windows also it is used. Okay, but it's very expensive. For example, in expensive cars. Nowadays, you can see in premium cars. Okay, that means which are expensive, like UV cut glass it is called. UV cut glass in the sense ultraviolet cut glass where it is polarized. And if you go for costlier cars means almost their windshields are actually polarized. That means more amount of light won't enter directly. Similarly, windows of aeroplane, windows of jet, all those are polarized. Why? Because they will be exposed to sun directly, right? Okay, no tree, nothing when aeroplane or jet flies. So in order to check that, what they use is polarized glasses they will use, where amount of light entering will be slightly less and it is more comfortable for those passengers. So automobiles it is used, aircraft it is used, that means polarized glasses. In sunglasses also it is used. One more I will tell you, what you know, you might be experienced this 3D movies. So 3D movies you are familiar. So when you go for 3D movie, they will issue you or they will give you a sunglass. Whether it is sunglass? No, it's just a goggles you can say. It looks like sunglass actually, but don't use that, okay, because it is made up of one thin sheets and it's not that good also. Only for movie purpose it is good. So that specs you can say, that glass you will get. Then you have to wear it and you can watch the movie. So there also that polarization is being used. So those are actually the polarized glasses. Okay, now it is being made because of nanotechnology and all. It has become very thin. Okay, it looks like plastic. Okay, leave it, nothing to worry. So these polarized glasses are there, right? Or polarized materials are there, right? Which is being manufactured. They have got one name. What is the name? Polaroids. Okay, write down. So name is Polaroids. So Polaroids. So what is this Polaroids? Okay. So this Polaroids means these are actually responsible for polarization. Okay, that means you have one glass. You want to make it polarized glass. How to make? You have to add or you have to mix Polaroids there. So what is Polaroids? So these are actually thin sheets of dichroic material. That means these are crystals. Okay. So thin sheets of dichroic materials, that means by using nanotechnology and all, these are being manufactured. So these dichroic materials are there, right? They are actually placed in between thin glasses. Imagine one glass is there, one more glass is there. This dichroic material is being placed in between them and now that glass becomes polarized glass. That's how it is being designed in sunglasses or all other glasses, which is usually called so-called polarized glasses. So dichroic materials, many examples are there for that. Okay, so just take down what is Polaroids. Thin sheets made up of or thin sheets of dichroic material used to produce plain polarized light. Okay. So how these dichroic metals will use? These are actually the crystals. Okay, tiny crystals of iodosulfate usually. So these are actually made in the form of thin sheet and they are placed along with the glass. That's how But while aligning also there is some procedures, like parallelly they have to align so that it makes a thin film and gets attached with the glass. So when you take one, what is that? Imagine you have two, what is that, polarized glasses. You can see in calculator, if you just imagine a calculator is there with you and the calculator is damaged, it's of no use. Imagine it's of no use means fine, then you take out the display of that, okay, LCD display of calculator, and just remove the glasses. Display glass is there, right, which is being attached together. Remove that, you will get some thin sheets there. So keep that thin sheet like this. You will make sure yes, light will pass. Make the thin sheet like this, perpendicular to each other. In classes I can show you, but right now it is not possible because it's video class. The visibility won't be correct. That's why you can see light won't pass. So that's how it is being used in 7-segment display, which I already told you people. So what is this? These are actually thin sheets of dichroic materials which are placed in between glasses in order to make it a polarized glass. So what are these tiny materials? These are actually, yes, iodosulfates. Okay, that means they are actually using the cellulose kind of, okay, what is that, solutions and all they will use. Okay, it's like different chemical combinations. So just remember as polaroids. Okay, polarized means these are the materials, dichroic materials, which are responsible for polarization. Okay, yes. So next, let us go for application or uses of Polaroids. So polarized means these are the materials which are responsible for polarization. So whether these are used directly, no, they are actually kept along with the glass. So glass will give the mechanical support for them. So what are the uses? Of course, you know, Polaroids are used in sunglasses. Yes, correct. They are used in Polaroids are used in which one? First application, uses, sunglasses. Second one, displays. LCD display we can see, but nowadays LCD displays are very less because everything is replaced by LED. But still, calculator and digital watch are still having those displays. So that's why displays of calculator and digital watch, still they are in use because TV, monitor of computer, everything is nowadays it is LED, light emitting diode they are using. So LCD is being replaced. So two uses. Next I told you, what is the third one? 3D movies, correct? So used to view what? 3D movies. 3D movies, sunglasses don't write, you just write used to view 3D movies, enough. Which one? Polaroids. Okay, those goggles which you are going to give. Okay, fine. Third application. Next, after that, I told you about aircrafts as well as automobiles. Yes, used in automobiles and aircrafts or aeroplane you can write. Okay, so 4 uses. So fifth one you can write. Usually in laboratory it is used to reduce the intensity of light which is entering. Okay, like that you write. In laboratory. Okay. Sorry, here U I have written. It has to be O. Yes. Laboratory. It is used to reduce the intensity of light which is entering. Why it is used? Imagine that a lab is there where, for example, usually what happens in your classroom, okay, early morning, those who are sitting at the left hand side, they will receive the sunlight. Exact noon, nobody. Exact direct ray won't be there. Evening, right side people, correct. So that is what usually happens. So like that, some of the sophisticated lab will be there, or laboratory will be there, where maybe some biological kind of experiment might be going, or some photosensitive materials experiment might be going, in which what has to be done is, imagine that a particular range of light is there. Only that much has to be received inside the lab, not much more than that. So you can ask, oh, is it? Then why they have to simply invest? They can use a screen, right? So that when it is having, okay, light means, okay, fine, put the screen, then remove. But it is man-made, right? In the sense, you have to be very careful and you have to be very attentive. You have to close, open, all those things. So it has to be done on its own. Like if you use a glass of the windows by using Polaroids, it will have its own capacity to check the amount of light. Constantly it will leave the ray of light to enter in. That is it. So that's one of the best application. Okay. Hope this is clear for you. Okay. There is no difficulty in this, I feel. Fine then. So that's all about Polaroids. Okay. So let me erase this. So one more important definition kind of thing, okay. It's a law actually, take down, that is Mallu's law, not Mallu law, okay. He is not from Kerala. Mallu's law is one of the scientists who actually worked on polarization concept. Like how Brewster's law, all those things, he also have worked on it, and he came to know that yes, some concept is there which he also capable of giving the theory. So he has given one law. What is that law? Let us see. So Mallu's law, diagram I will draw. So these are crystals, okay. So pass axis means you know already. So polarizer, analyzer. Two crystals are there. Like this. So let me, instead of taking dotted line, I will take straight line. Okay, better do that. I'll tell you later why. So let us take, this is the pass axis which is already maintained from the polarizer, analyzer. Okay, polarizer I will write P, analyzer A. And I don't show any, what is that, vibrations of light, all those things, because you are already familiar. So you can make, look at here. According to Mallu's law, when unpolarized light passes through, what is that? A polarizer, a plain polarized light will emerge out of the polarizer, right? Once it starts going through the analyzer, if the analyzer has the pass axis same as that of polarizer, means fine, you will get light at the output. Imagine that analyzer has got its pass axis slightly in different angle, okay. Imagine this is theta, Hope you can see it. Can you see theta? Yes. So the pass axis of analyzer is slightly tilted, is rotated right side. So theta you can see there. Yeah. Fine. So now according to him, he says that once ray of light, that means unpolarized light, passes through this, the intensity of plane polarized light will be one particular value. That means right now it is vertical pass axis, so vertical vibrations will be there, one particular intensity will be there. Then what about the outcome of this? If the pass axis of the analyzer starts shifting, he has given one equation. What is that? I is equal to I naught. Intensity of emerging light is I. I is equal to I naught. When this is straight. When it is tilted, cos square theta. So this is the equation which is given by him. Very important equation. Remember this. Okay. So what he said? He says that when a beam of light which is completely plane polarized, incident on analyzer, the intensity of emergent light is directly proportional to square of the cosine of the cosine. You can see there, no, cos square. Square of the cosine of the angle between plane of transmission of analyzer and polarizer. Okay, it says that like this: I is proportional to cos square theta. This is the law. And how he has explained, I is equal to I naught is a constant, cos square theta. So what we can say, when a beam of polarized light is incident, like that you can explain, okay, no problem. Unpolarized light is incident on polarizer. The light is completely plane polarized. When a beam of plane polarized light is incident on analyzer, the emergent light, the intensity of emergent light is proportional to square of cosine of the angle between what? Angle between the transmission of plane of transmission of analyzer and polarizer. Okay, plane of transmission of angle between plane of transmission of analyzer and polarizer. Here polarizer is exact same, that means 0 degree. Here whether it is 0 degree, no, some angle is there. So what is the angle difference? Theta. So this is what the explanation is. Okay, take down like how I have explained neatly. Okay, there shouldn't be any confusion. Hope this is clear for you. Malus law, for 2 marks usually it is asked. So what is the explanation of Malus law? When a beam of unpolarized light is incident on polarizer, that polarizer has got its own, yes, polarizing, yes, particular pass axis. Once the completely polarized light is made to fall on the analyzer, okay, the analyzer also checks whether it is polarized or not. So once it comes out, you can say, okay, it's a polarized light and its angle of tilting is like this. So according to this law, what is the explanation? The intensity of emerging light, okay, intensity of emerging or emergent, you can say, no problem. So intensity of emergent light is directly proportional to square of cosine of the angle between plane of transmission of analyzer and polarizer. So that is how you have to explain. That's all about Malus law. Okay, fine. Hope there won't be any confusions now. So let me go for last one small topic. So remaining is optical instrument, okay, microscope and telescope. That's the last topic. Thereafter we can go for numericals in this chapter. By that, chapter is over. So now, polarization by reflection you have seen. Let us go for, so just diagram, okay. Polarization by scattering. Polarization by scattering. I can show you diagram. It's just a small topic, okay, just for knowledge purpose. Imagine a molecule is there, okay, like this, and a ray of light is incident on, that means a molecule in atmosphere you can take. Okay, what is the ray of light? Rays of light, what we are getting right now is there, no? We cannot say it is exactly unpolarized. Sometimes it is polarized also because of scattering of light takes place, okay? Z axis, Z, Y, X axis, like this. Now what happens in scattering is, unpolarized light will be incident on a molecule, okay, like this. Unpolarized light. In all the direction it will be having. Scattering means, of course, you know what happens in scattering. Deviation of direction of light takes place, okay. Which scatters more in sky during daytime? Blue color, correct, like that. That means which has least wavelength. So once a unpolarized light is incident on a single molecule, okay, we will write this is molecule, scattering takes place, correct. When scattering takes place, the light which goes along, okay, the Y plane, you can see here, is completely polarized, okay. That's what experimentations are being explained. What about the remaining one? Here also polarization takes place, like this. This is also plane polarized. That is also plane polarized. Both are plane polarized. Plane polarized. Plane polarized. So how we can explain this? We can see when unpolarized light is incident on a molecule, polarization takes place by scattering. So how it looks, look at here, how the distribution of polarized planes here. Okay, when beam of light passes through a medium, okay, which, whatever medium, because you know Raman scattering, correct, there also same concept has happened, scattering of light has taken place, like that. When a beam of light is actually incident on a molecule or is actually incident in a medium, when it strikes a molecule, scattering will takes place. When scattering takes place, when light viewed from direction perpendicular to the direction of beam of light is found to be completely plane polarized. Okay, so when it is watched from a direction perpendicular, that means from this X direction light is coming, from Z direction if you see means you will get a light which is plane polarized. From Y direction if you see means you get what? Plane polarized light. But how they are polarized, you can see if it is having vertical vibration, horizontal vibration will be there. So this is how polarization takes place. In which one? Polarization by scattering. Okay, so in students, in today's topic, what we have done is we have learnt about representation of, what is that? Yeah, polarization of light, unpolarized, partially polarized. Thereafter polarization by reflection we have discussed. What is polarizing angle we have discussed. For different metals like water as well as glass we have discussed what is the polarizing angle. And a very important small derivation that is stated and explained, Brewster's law we have discussed. Thereafter we have discussed about what? Polaroids we have discussed. Application of Polaroids we have discussed. Malus law, one of the important law it is. Malus law also we have discussed. And finally Polarization by scattering we have discussed. Remaining is small two